Okay. I want to talk about where we left off on Wednesday, and then we're going to do a hands-on activity. So I kind of want to wrap up Wednesday pretty quickly and then get to our hands-on. Do you guys remember on Wednesday I kept talking about dropping watermelons off of things?
Yeah.
I didn't for real, but I really want to. I wish it was a little bit warmer outside, and I wish I had lots of money for watermelons, because that would make this way more fun.
Yeah.
Okay. So say I dropped a watermelon off the roof of the school. We're going to pretend that the roof of the school is 25 feet tall. When we just drop something, that's free fall. If I just lean over and drop my watermelon, what is the initial velocity? Like right as my hand releases it, how fast is that watermelon going?
As fast as it is gonna go. Wait, I'm so.
Like before it even starts to fall, like right as I release it, like if you could do stop motion, how fast is it going? 0. All I did was take my hand off it. I didn't put any force behind it. I didn't throw it down. I didn't throw it up. I didn't throw it at all. I just let it go. So its initial speed, or its initial velocity, would be 0 feet per second.
Is it in the book?
This is not in the book. The hands-on activity is in the book. I want to write a function that expresses the watermelon's height as a function of time in seconds. So what we left off with on Wednesday, oh, that's a horrible color right now. That's a little bit better. H is equal to negative 1/2 g t squared plus v naught t plus h naught. I really don't know why they say naught. I have a bit of a clue, because it's not N-O-T, it's not like no, it's N-A-U-G-H-T, like an old English word that basically means nothing.
So what
Or
about
0.
velocity? I thought that was velocity.
You thought what was velocity the whole time?
Yeah. V.
Yeah, v naught t is the initial velocity
Oh.
multiplied by our time. So the v naught part, this, you're right, that's our initial velocity.
How do you put the knot in the calculator, or how do you write that?
So you don't put the naught in the calculator. That little number right there is telling us the time. So this is velocity at time 0. That's what the little 0 next to the h means. It's the height of the watermelon at time 0, or at the beginning. So anytime you see this show up in any kind of formulas, oh my goodness, there we go. Anytime you see a little 0 next to a variable, they're just saying, what is the, whatever this variable stands for, at the beginning, or initially. So initial height. So let's see if we can write that for this situation. So my height is equal to, what do I need after the equal sign?
1/2.
1/2. What about that 1/2?
That is
Negative. Why is it negative?
because you drop down.
Because you're dropping it, it's going down. And what does the G mean?
Gravity.
Gravity. Gravity is going to pull it down. Most of the time our velocity is sending things up, because we have this what goes up must come down. Okay, 1/2. What can I put in for G? We talked about this on Wednesday. There were a couple numbers. I don't expect you to memorize them, but we did look these up. Yeah. So gravity itself is 32, but then we simplified it because half of 32 is where that 16 came from. Y'all finished? Awesome. Absolutely, you may. So I have half of 32, which is going to simplify to 16, plus my initial velocity. Oh, wait, I forgot the t. T squared. Plus, what are we going to put in for our initial velocity?
25. Oh, zero.
0 for my initial velocity. And then I want my initial height after that. 25. I don't know why they have a 15 on the graph.
Oh, wait. Oh, that.
25 came from up here. I do not know why it's a 15 on the graph. I grabbed the words verbatim from the book and the picture. And then after I got them up, I looked down and I was like, that does not match. I'm not the only one that makes mistakes. And then from here, I'd want to simplify it. We already know how that 1/2 times 32 simplifies. That's going to be h equals negative 16 t squared. Can I simplify anything else? 0 and t. What's 0 times t? 0. So that'd be 0 plus 25, which is just 25. Anytime we have an object in free fall, my initial velocity is going to be 0. So if we're just dropping things like toddlers off of a high chair, my initial velocity, not the child, but toddlers like to drop things off of high chairs. That sounded really horrible. Let's drop toddlers off buildings now.
For an experiment.
See, and this is how viral videos go viral. Somebody's going to catch me saying that, and then it's going to show up, and next thing I know, I'm going to get called into Mrs. Mitchell's room. Like, what's this viral thing that I hear about you throwing toddlers off of buildings? Okay, again, I don't know why it has these numbers off to the side. This is modeling dropping something off a building, though. Does this picture right here actually model the path through space? Like through a 3-dimensional environment? Am I seeing how far away from the building this is going to land?
Well,
So what's it showing me then?
Well, if the bottom is
What are the variables that we have in our equation? Because that's a great point. If the bottom is feet, then yes.
initial height and velocity.
I'm looking right here. What do these variables mean? Height and time. Which axis does the height go on? The y-axis. And time goes on the x-axis. So it's not showing me how far away from the building it's going to land. If I had a video of this and I hold a watermelon out and I drop it, I'm just going to see it go straight down. But if I had some way of moving that video for like each second, like if you could see on YouTube, you know how like when you edit videos, you can see where things are at each point. If I had it side by side like that, then it would appear to stretch it out this way, and then I would see this arc. It's showing me the height relationship to the time, not to that horizontal distance on the ground. Okay, one more last piece of wrap up, and then we'll get hands on. I want to go through this next part as quickly as we can. So we did a projectile motion example on Wednesday. And we had this function right here. I want to know where each of those numbers came from. What does the negative 16 mean? Where did it come from? What'd you say?
It's when you use the 32, I forget.
Yes, negative 1/2 and times the 32. Where did the 32 come from? Starts with a G. Gravity. This is the acceleration due to gravity. Okay. Where's the 5 coming from?
It's
The initial velocity. And last but not least, the initial height. So considering the fact that nobody in this room is an astronaut, I'm not either. I'm not planning to be in the future. So we're staying on Earth. Which of those values, the -16, the 5, the 15, which of those can change? Assuming that I'm staying on Earth, which of those values are free to change? Initial velocity can change, and the initial height can change. That -16 is never going to change because that -1/2 is a constant. I could explain how to get there, but it's going to take a while and y'all will get very bored. It's a calculus thing. We'll just leave it at that. And then the acceleration due to gravity. We're not leaving the planet, so that stays constant. I want to consider what would happen if we did change the height. So I'm going to draw some quick sketches. In my free fall, hey Barry. In my free fall, dropping the watermelon off the building, I had a graph that looked like this, right? I don't have it on here, but the other side of the parabola is like this. I don't have it on there because that's like negative time and that's not a thing. What happens if I stand on something taller? My y-intercept would be higher. And so my parabola would look like that. Again, this side wouldn't actually exist, but that's what my parabola would look like. My parabola is not getting wider. As I move it up, though, because parabolas naturally spread out, as I move it up, I'm going to see the bottom of it appear to be wider, but not because the parabola itself is wider. Does that make sense? Okay. Or I could be standing in here. And then it would be like that. So that's if my height changes. What if my initial velocity changes? So that first parabola was like this, and that was just free fall, right? What happens if I stand at the same height, but I don't just drop it? I throw it. Yes, if I throw that watermelon up, it is eventually going to come back down, right?
But it's going to come back like...
It's going to go up first, and then it's going to come down. I did a really bad job of drawing it, but you guys get the basic idea, right? What about if I throw it even harder? It's going to go up a lot more. Like maybe I do a really good throw. These aren't looking like parabolas, but they're supposed to. It's my drawing skills. It's not reality. Okay. What I want to do with you now, we're going to kind of change gears, but we're still talking about and looking for these patterns. This is on page 79 in your books. And you're going to want that workspace in your books. I've got some hands-on models so that we can think through this also. Yay! Squishy dice. First thing I want to answer about this is how many cubes are needed to build this tower right here. So I want to start to kind of model this out for us, and I've got little cubes. I don't have a ton of them, like this is all I've got, so I'll pass some out to each group, but hopefully that will be enough for you guys to start to find some patterns and to be able to move things around. How many layers tall is this tower right here? 6 layers tall. How many of these cubes would I need if I wanted to build just a 1 layer tall? Just the very top. I just need 1. So that's what I need if it's only 1 layer tall. What about for 2? So I've got this. That's part of that center column, right? So I'm still going to need this even in the middle, or even in the second layer. And then it's got a block on either side, and front and back. So how many blocks am I up to right now? 5 blocks, and then I still need that one on top, right? So how many blocks total? 6. 5 here in layer 2, and then 1 on top.
So you're just trying to cover up the whole one dot?
Yeah, because if I take this one out,
It's just gonna be 5.
I don't have a tower. It's going to fall through. If I want to build a tower, I have to have something underneath it that supports it. So 1, 2, 3, 4, 5, 6, right? What about for a 3-level tall? Tell me what I need to do to model this here. How can I build it up? What's going to have to change about it? What's the new base going to look like?
It's gonna. Is it gonna be 8? It's gonna be 4 like around.
Yep. I need 4 more around it, right? Now I need 4 more here to build this one up so that the second layer looks right. And then 1 on the top. How many total? Let's slice it like a layer cake. How many do I need for the top? 1. So there's my top layer. How many do I need here?
5.
I don't know if I can do this. How many do I need here? 9. So 9 here,
5.
and then 5, and then 1. Can I do the next layer?
Yes.
Okay, how many am I going to need? Talk to me about how I build this. Add 4 to the third layer. So how many is that going to be on the bottom now if I add 4 to what was the bottom? 13, because it was 9, right? I just made that 4 bigger, so now it's 13 on the bottom. And then what?
It's gonna be 4 over.
Add 4 to the second layer, so it's 13 and then 9. And then? And then 5. And then 1 on top. I only have it up to 4 layers tall. I want to know how many cubes are in this tower. And you said it's how tall? 6 layers tall. I'm going to pass out some of these cubes here so you guys can model it. You are welcome to work together in groups. But I want you to be able to tell me how many cubes are needed to build this one, how many cubes are needed to build a tower that is 12 layers high, and then how many cubes would you need to be able to build a tower of any number of cubes tall? I want to know, on page 79 of your book, how many cubes do you need to build that tower? You have these to kind of model with. That tower. Some more. Who else needs some more? A couple more here. All right, that's all I got. You're welcome. You guys are welcome to share if you want to build higher and higher. Thank you. I really want you guys, in addition to trying to model this out and come up with an answer for how many you need, try to find some patterns. Because I definitely don't have enough blocks to build this up 12 layers high. Plus, I think even if I did, they'd start to fall apart. And it gets really hard to count.
If you kind of cut it in half, it's like 6 of them.
Try to find some patterns. Model this up. 79. Underneath the screen.
I feel like those sharp edges were
That's what I did.
I'm hearing a lot of good conversations. I love this. Please keep talking together about this and try to look for patterns. There's 3 parts to this, and I want you guys to definitely get all the way to the 3rd part. How many cubes do you need to build the tower as pictured? How many cubes would you need to build the tower that's just like that, but 12 cubes high? So you're really going to want to find patterns to be able to do that. And then how many cubes would you need to build a tower that is n cubes high? So I'm looking for more like an expression where you have a variable. And n stands for how tall that is. Okay? So, couple things quickly. Guys, please make sure that you say goodbye to Miss Yeager. Today is her last day. We will miss her. Also, your e-learning assignment, there were 2 pieces to it. It's due on Monday. So if you did not get that done, you still have until Monday when it's due. Have a great weekend, everybody.